Good afternoon, good morning, good evening, depending on the time you are seeing this video. You are welcome to the Dawn's Consult, where we make chemistry very, very simple. And today I've come with an interesting topic, and that is on periodic table. And what are we going to discuss under this? We want to see how to identify the group end or period and element belongs to in the periodic table. Oftentimes you'll be given questions in your WAEC, JAMB, NECO, and all kinds of exams that you write. Those of you watching me from outside the country in your high school terminal exams, like my students in UK and Scotland, your N5 and all sort of exams, even your IGCSE exams, you'll be asked to identify the elements to the group and the period such element belongs to. So I have two examples here, but before we go to the examples, I want to teach you two methods that you can use. Now, mind you, you know how to write electronic configuration in this format, all right? Now, if you write electronic configuration in that format and it ends with one electron on X orbital, one electron on X, that means maybe X having one electron like this, all right? We say it belongs to group 1, all right? If when you have it, you have two electrons on the S orbital, two electrons on the S orbital, that means something like this, either 1s, 2s, 3s, or whatever, 4s, or whatever. There are two electrons on the S orbital. It is in group 2. Okay? And if you have two electrons on the S orbital, let's say S2, of course, that's the final electrons on S2. S contains maximum number of 2 electrons. S2 and one electron on the P orbital. It is group 3. All right? Then you have 2 electrons on the S orbital and 2 electrons on the P orbital. Well, other call it orbital. Just understand what I'm trying to say. That is group 4. All right? Then you have 2 electrons on the S orbital and 3 electrons on the P orbital. That is group 5. All right? Then if you have 2 electrons on the S orbital and 4 electrons on the P orbital, that is group 6. All right? Then if you have 2 electrons on the S orbital and 5 electrons on the P orbital, that is group 7. Mind you have up to group 8. Is that right? Then if you have 2 electrons on the S orbital and the P orbital is saturated with 6 electrons, then that is group 8, or you say group O. All right? So when you have these electronic configurations, that is how to identify the group the element belongs to. This is for group. All right? Then how do you know the period? The period. Okay, maybe before I go to the period, let me give you another method for this. Another method you can use to identify this is to say number of electrons in the valence shell. Number of electrons in the valence shell. Number of electrons in the valence shell gives you the group. These are another method. This is method 1 and method 2. If you cannot use this method, then you can use this method. Number of electrons in the valence shell. What is the valence shell? Valence shell is the last shell. All right, number of electrons on that valence shell. That's when you use this method. This one. This is the valence shell. Now, if you have only one electron on this valence shell, mind you know that this one will be 2 electrons. Then this one will be 8 electrons. The number of electrons here, all right, will determine the group that element belongs to. Then the number of shell for period now. For period, to identify the period an element belongs to, you just say number of shells. The number of shells tells you the period the element belongs to. So in this case now, How many shells do I have here? I have 1, 2, 3. There are 3 shells here. So the element that will have 3 shells will belong to period 3. And how many electrons do I have at the valence shell? I have 1 electron at the valence shell, so it will belong to group 1. That's if you don't want to use this method for the groups. I hope you understand. All right, let's see these 2 examples now, so that we don't make this video unnecessarily long. All right, so the questions say they are past wire questions. All right, this one says, given that the electronic configuration of an element X is, this is the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p4. Now say it can be deduced that X, they give you options. A belongs to group 4 in the periodic table. B belongs to group 4 in the period 4 in the periodic table. Then C contains 3 unpaired electrons. Then D has atomic number 27. Now the first thing you know this one is wrong, because the atomic number here is, this is 2, 2, 6, 4. So this is 2, this is 10. So there are only 16 electrons. 2 plus 2, 4, plus 6, 10, plus 2, 12, and plus 4, that's 16 electrons. So now, if I want to use this first method to know the group the element belongs to, this is the ending. This is the ending. Can you see? That is 2 electrons and 4 electrons. 2 electrons on the s orbital and 4 electrons on the p orbital. So if you look at this now, 2 electrons on the s orbital, 4 electrons on the p orbital. From what I discussed, this is group 6. So this element is in group what? Group 6. It's in group 6. So A say belongs to group 6 in the periodic table. But let's see the period it belongs to. Have 10, and so the first shell will be 2, second shell will be 8. They're out of how many now? This is 10, 16. So the next one will be 6. So you can see there are 3 shells. So that will be period 3. So do you have anything like that? Let's see the options. Belongs to period 4. That is wrong. So the answer is A. The answer is A. It belongs to group 6 in the periodic table via this method. And if you want to use, look at this, the other method, and the last shell too is 6 electrons following the second method. Can you see that? The last shell is 6 electrons. That means relating to this. That means giving us, and I told you before that this valence shell, the number of valence shell electrons is the period, is the group. So this is group 6. Following this first rule is also in group 6. Do you understand that? That's how simple chemistry can be. And here in the DOS consult, we make it simpler. All right, let's see question 2. It said an element Y has the electronic configuration 1s2, 2s2, 2p6, 3s2, and 3p3. It now says, where is the element located in the periodic table? A, group 3, period 3, group 3, period 5, group 5, period 3, then D, group 5, period 5. So let's see this. Let's use the first method. The first method is having 2 electrons at the s orbital. Forget about this number. This is just the energy levels. I hope you understand that these numbers are the energy levels, and the numbers above are the number of electrons. This one shows the lowest energy level. This is another energy level. This P, these numbers before. Okay, I hope you understand that. Okay, so now it ends with 2 electrons on the s orbital and 3 electrons on the p orbital. So from what I discussed here, we'll have 2 electrons at the s orbital and 3 electrons at the p orbital. That is group what? Group 5. It is in group 5. Group 5. That's group 5. All right. But let's see the number of period it is. How many electrons do you have here? This is 2 plus 2 plus 6. That is 10 plus 2 is 12 plus 3, 15. So we have 15 electrons. So that will be 285. 285. How many shells? This is the first shell. This is the second shell, and this is third shell. So we have 3 shells. So if I will have 3 shells, that's to tell us we have it belongs to period 3 of the periodic table. So let's go to so it's in group 5. No, where is it? Yes, group 5 and period 3. So which option have group 5 and period 3? So let's see, this A is group 3 period 3, no. Group 3 period 5, no. Then group 5 period 3, that's correct. This is the correct answer. Do you see that? That is how simple chemistry can be. Here in the Dawn's Consult, we make it even much simpler. Like this video, please share and call your friends to this channel. We are here to make chemistry very easy for you. And of course, if you want private tutor, my number is there on my channel, on the profile. Link me up. Distance is not a barrier. We'll make chemistry very, very simple for you. Thanks for watching. Please like this video, share, and comment. Thank you. Thank you.